Hello everyone, my name is Sigrid Bjørndal. I'm from Soprasteria, and today I'll talk to you about BERT, which is a really exciting new language model from Google, which is quite new in itself, but also has some really exciting new development, which I'll talk about later. So first I'll talk a bit about what BERT is. Just a really quick overview. To quote Jacob Devlin, who is one of the creators of BERT, BERT, or bidirectional encoder representations from transformers, is a new method of pre-training language representations which obtains state-of-the-art results on a wide array of natural language processing tasks, also called NLP tasks. Okay, so what does this actually mean? So it's a new method of representing a language. It was published in 2018 originally. And it's a general purpose pre-trained language model. Pre-trained in this case means that it is not trained on task-specific data, but rather on more general data sets. And the model can be used for a lot of different natural language processing tasks. And just a quick fun fact, BERT was named after Bert from Sesame Street, or Sesam Stasjon for the Norwegian listeners here. It's been a trend in recent years to name models after cartoon characters, in particular Sesame Street. So first of all, what is NLP? NLP stands for Natural Language Processing, and natural in this case refers to human languages. It is a subfield of AI relating to human languages with a lot of subfields under NLP again. And examples of common NLP tasks are, for instance, sentiment analysis, which refers to analyzing the sentiment of documents or utterances or short text messages like tweets or Facebook posts or other social media. This is quite useful for instance, evaluating whether a customer is satisfied or not, whether there are bad or good news for a certain company, which could affect the stock price, for instance. And there are other more complex tasks that NLP can contain, such as document classification, which is kind of self-explanatory, or email handling, such as, for instance, forwarding incoming emails to the correct people, which is especially useful if someone has a general inbox email for an entire company, and so NLP can do a quick sort rather than some poor human having to filter through all incoming emails. And chatbots are also an example of an NLP task. So how does AI actually learn a language? This is a non-trivial task, which I'm sure all of you know, in particular if you've ever tried learning a foreign language. And just to illustrate one of the problems, Norwegian has over 300,000 words in the dictionary, while English has around 500,000, and this results in a severe case of the curse of dimensionality. If we were to represent all these words in a new way, we would have extremely high dimensionality and extremely high sparseness, and this entails that we would also need extreme amounts of data to do basically anything, unless we somehow manage to reduce the dimensionality. Adding to this is the fact that the language is complex and data is limited, in particular labeled data, good labeled data for any task. And so you often have too little data to both learn the task that you want to perform, but also learn the language from scratch. And so one solution to this are word embeddings, which split this problem into two parts. You first learn the language, and then you can worry about the actual task that you want to perform. And word embeddings are quite a clever idea for reducing the dimensionality. It uses numerical vectors to represent words, where the values of the vector encode the meaning of the word. So, and these vectors are often in much lower dimensionality, typically 500, 1,000, thereabouts, as opposed to 300,000, which is a quite large improvement, I would say. And a central concept here is that words with similar meaning have similar vectors. So to use this toy example, want and need are two verbs with quite similar meaning, and so they are close together. Mortgage and loan are also quite similar to each other, but they are dissimilar from the two verbs, and so they are far apart to that pair, but close to each other. And if we extend this to the entire language, we can actually do inference and reasoning based just on these embeddings. And good embeddings encode the language in general, so you can reuse embeddings across applications, because learning these embeddings is a quite difficult and expensive task. So how do we learn these embeddings? The guiding principle for this is that words with similar meanings occur in similar contexts. So that, to use the toy example here, the words mortgage and loan can be used somewhat interchangeably, such as someone needs a loan to buy a house, or someone needs a mortgage to buy a house, or someone needs something, someone wants something. And these similar contexts, when they occur over in a very large data set, together give a quite good representation of what words are similar or dissimilar, and therefore also a way to represent them in a meaningful way. And the way this was done before BERT was that first you need to gather a large unlabeled dataset of text. And we mean large, like huge, like gigabytes of data. Typically, the text set like the entirety of Wikipedia, a library of digitized books, an entire archive of news articles, with the other complexity of dealing with data quality. And then you train a neural network to predict a word based on its context. And this training process and the resulting neural network result in embeddings for the words, but just a single embedding per word, regardless of what it means in different contexts. And then you can use the embeddings to do your actual task. So we have quite a few steps, quite expensive steps that might take a lot of time and a lot of knowledge and fine-tuning to get right before you get to your actual task. And there are also some other problems with this traditional approach. Words are ambiguous, so this traditional approach gives a single embedding for a single word, but some words might have widely different meanings depending on the context, or have extreme amount of different meanings. And just to take a simple example, the word play can be a noun or it can be a verb, and if it is a verb, it can have a lot of different meanings. You can play with a ball, for instance, or you can play an instrument, or you can use play in a more in a completely different way. But the embedding itself doesn't say if we mean what meaning of the verb play we use, or even if it is a verb, or it should rather be a noun, like a theater play. And in addition to this, learning embeddings from scratch is expensive. You need large amounts of data, time, computing resources. And so it is useful to use pre-trained models where someone has done this already, done the work for you. However, good pre-trained models, in particular for small languages, such as Norwegian, are really hard to come by. It's been some developments in recent years, but with traditional methods and before now, it's been just a few quite bad models available, to my knowledge. But we now have a solution to all this, and the solution is BERT. So a few highlights about BERT. It was published by Google in 2018, and they have recently actually implemented it to improve search results, for instance. It has achieved state-of-the-art results on several NLP benchmarks, which is all well and good, but quite abstract and quite research-focused. The game changer here is that both pre-trained models and code are available under an open source license, where you can do basically anything with them, like commercial use or modification or anything really. And as of now, there are several language models available. There's one for English. There's a multilingual one, which supports over 100 languages at once, but usually a single language model performs better. And just a couple of months ago, there were models published for the Scandinavian languages, so Norwegian, Swedish, and Danish, which are also free to use under an open source license, although not published by Google. So how does BERT work? It is pre-trained on several gigabytes of text data. Different models are trained on different data sets, but common data sets include Wikipedia or digitized books or news articles and so on. BERT itself is an extremely large and complex neural network, so I won't go into detail about that architecture now. But if you're interested, there are several resources available online, as well as the original paper. The main feature of BERT, and the great breakthrough with the model, is that the embeddings are no longer static. They no longer represent every different meaning of a word in one single embedding, but rather they now use its current context, as well as the knowledge it has learned about the language during the pre-training. And what is also quite useful here is that BERT generates an embedding for entire sentences. So instead of interpolating the meaning of a sentence from the meaning of its words, you can now get the meaning of the sentence directly from BERT's embedding. So how do you use BERT? What can you use it for? You can basically use it for any NLP task, such as sentiment analysis, document classification, email handling, anything you can think of relating to language, basically. But you do still need to train a model to actually perform the task. So it doesn't do all the work for you, but it brings you quite a far way along the road. And one of the big advantages here, the biggest I would say, is that you need much less data and time and computing resources and knowledge to use BERT rather than the traditional methods where you do everything yourself. So I'll give you a few technical details of how you can actually use BERT, how you can implement it. First, you need to download code and a pre-trained model of your choice. The code is both published by Google and by another organization with support for TensorFlow and PyTorch. So it's your choice there. And you don't need to really think about how BERT works. The APIs for BERT are quite good. So you just give it input and then you get output. And you also need to gather usually labeled data for your specific NLP task, such as labeled emails or labeled documents or messages with the sentiment already labeled, to use the previous examples. And these data you pass through BERT. You just give it the input data, typically separated into sentences, and then you get output. You don't need to worry about anything in between. And BERT can give you either word embeddings or sentence embeddings. So either the meaning of each word or the meaning of each sentence. And these embeddings you can then use to teach an AI model to perform your task. And there are several models you can use for this, either neural networks or more traditional methods. And what's nice about the fact that the code and everything has been published is that you can, if you have the time and resources to do so, you can make the embeddings even better for your specific domain by continue its pre-training on your own data. So say, for instance, that you are a financial organization or working in a specific industry. You can take a lot of unlabeled data from that domain and feed it to the model to make it more specialized. Because BERT is really a general purpose model. It knows the language on a quite general level, but it might not be quite as good on really technical language. But again, you can just use it as is. It is perfectly capable of that. I myself have used it to great effect. It gave a 20-point increase in accuracy compared to traditional models. So it's definitely something to keep in mind if you ever encounter an NLP task. So to summarize, BERT is a new state-of-the-art language model from Google. It can generate either contextual word embeddings or sentence embeddings. And again, embeddings are a compact way of representing meanings in the form of numerical vectors. Both code and pre-trained models of BERT are available for several languages, including Norwegian and other Scandinavian or really any common language you can think of. All under an open source license that allows for commercial use. And the biggest advantage of using BERT compared to any other method is that you may need much less data than before, as well as less time and computational resources, with the bonus that you might get away with using a simpler model for the task itself, as it doesn't need to actually learn a language before you get to learning the task. Thank you. If there are any questions, please send me an email or contact me in another way. And I hope you have a nice day.